Yeah, so hi, my name is Patrick Kettner. I am a program manager on Microsoft Edge out at the mothership in Redmond. And I'm here today to talk about progressive web apps. Quick survey of the room. Who here has heard of progressive web apps before today? Awesome. Who here can define what a progressive web app is? Cool. Who here's built a progressive web app? All right, cool. So just to give you a quick overview of what we're going to talk about, it will be progressive web apps, which is kind of effectively a marketing term to define a collection of new APIs that allows the browser to access more native app-feeling experiences in the web. It's something that we're working on Microsoft Edge. It's already come to Google Chrome, and other browsers are working on it as well. We're going to go over some high-level features, the things that generally are considered to make up a progressive web app, and then some more deep-divey stuff into actual implementation. So, like I said, I work on the Microsoft Edge team out in Redmond. If you ever try and find me on the internet, that's my avatar everywhere, and despite the shirt, I do work at Microsoft. That's actually just it's kind of a long story. Every year, my partner Katrina makes me cakes for my birthday, and they're around themes and stuff, and so it just happens to be one of the more popular ones. That's Katrina. She normally is with me when I go places right now. However, we're in Orlando, so she's with our kid over at Disneyland, or Disney World. And, you know, it's funny, he's our first child, and when people tell you you're going to be a parent for the first time, they always tell you that, you know, it's get sleep while you can, or, you know, things are going to change when you're a dad or whatever, and it's really not the case with him. He's the easiest baby in the world. He was really sick here. He's fine now. He had a 103-degree fever, but he was still chill as hell. Like, he just is really calm all the time. They almost didn't let him into the hospital. He got better. He became a lumberjack, because we're from Seattle. You can be a web developer, a barista, or a lumberjack, effectively. The one thing that he hates, though, the only thing that really gets him mad is being in his car seat. He hates being like strapped in or whatever, and so he freaks out whenever we actually put him in there. And it was fine at first, but after a few months of having him out in Seattle in our apartment the whole time, we got a little stir crazy. We wanted to go on a vacation up to Vancouver. It's a beautiful part just north of Seattle. If you don't know where Seattle is, just to be clear, it's right there, upper left-hand corner of the country. Some people are international, you never know. We were trying to go to Vancouver, which is just right above that. It's about a 2.5-hour drive. And I was worried about him in the car for so long, and so I did what most nerds would do, and I went online and tried to figure it out. And I found this video. And for whatever reason, I don't understand how babies' brains work, but this calms him immediately. Whenever he's upset, whenever he cries, seeing this, he just immediately zones in on it and stops within literally a second every single time. Something about the movement or the distraction, I don't know, but it works. And so I was like, haha, I finally, conquered him. And so, we get into the car, we strap him in, he freaks out, I show it on my phone, and he's completely calm. We drive all the way up to Vancouver, get to Whistler, and everything's great. He's happy, he's chill. That's when we were parked, to be clear. He wasn't like hanging out on the side of the car for the drive. But we had a great day. He was chilling. We got to see the Olympic Village and stuff. And after a while, a full day up there, it had been about 8-9 hours. We had a 3-hour drive back to Seattle. And so we decided to get back into the car. I strap him in, and he starts crying, as he always does. And I'm like, aha, I got you now. Pull out my phone, and I show it to him, and I get this. And it keeps going. See, I have T-Mobile, which gives me data in other countries, but it gives me Edge data in other countries, not the browser, the incredibly bad cell phone speed. And a YouTube video that's 50 megabytes of a whole bunch of dots dancing doesn't really load quickly at all. In fact, it takes a really, really long time. And I don't know if any of you have ever tried to help your baby and they're still upset, but it gets exponentially harder every second that goes by, especially when you've guaranteed your partner that everything would be fine because of this video. So, after a while, I'm getting more and more upset. I'm getting, and he's getting upset, and we just eventually hit the road anyway. He's crying the whole time, and I'm just really irritated because, this 2G connection completely ruined my day, right? Like, we had a great day, everything was fine, and then, I was, once I started going through kind of the stages of developer regret, I realized that it wasn't the device's fault, that it was actually my fault for planning. So it was the 45 megabyte video that ruined my day. It's just a whole bunch of dots. There was no reason to rely on this gigantic video file in order just to display little things. I'm a web developer. I'm a developer in general. I should be able to create that much smaller. So get back in the car. I'm determined that this will never happen again. So I get all the way back to Seattle, get my kid in bed, open up my laptop, and stare at Vim for like 3 hours because I have no idea how to make dots on the web because apparently I'm not that good of a developer. But I have kind of a motto when I'm developing stuff, and that's if you don't have a better idea, just buy a novelty domain, which is what I ended up doing. And eventually I figured it out. So I got this website, Hush Little Baby, and if you go to it, you get this. It's the exact same thing in the video, but in less than 6 kilobytes. It does load an audio file, which is like a megabyte, but it lazy loads that in the background, doesn't block the actual rendering of the website. And what's great is that it works without a data connection. Once you've loaded it the first time, of course, you need it to load the initial load. But after that, it will continue to load even if you're offline. And the way it does that is one of the fundamental pieces of progressive web apps called service workers. So a service worker is a really interesting piece of technology. It's one of the most exciting things that have come to the web in a really long time. And it enables, basically, you can think of it as like the backbone of most of progressive web apps. Effectively, what it can do is it can add support through a service worker. You're able to add support for things like push notifications, where you actually get, even if the browser's closed, you get a native push notification. It can open the browser. It can open a new tab in that same browser. You can do all kinds of stuff. Background sync. So say you've ever tried to send an email in your Outlook or Gmail and you have to close the tab and it's like, hey, we're still doing that. You want to go or cancel? You no longer really have to worry about that if you enable background sync inside of a website. Inside of your website, we can continue to upload that data in the background. Even if your user goes offline or the device loses connectivity, the browser will resume that upload once it comes back online. There's also stuff like and it also can do things like powering offline experiences. This is something that we've been trying to do for a really long time on the web. Service worker finally is the first time that really feels right as a developer, and we're going to dive into that. But you know, the offline experience is something that we've been trying to do at Microsoft for over 20 years on the web, and we never really got it before now. See, it started probably in Windows 95 with the concept of HTAs. Does anybody remember those things? Just me? Oh, hey, cool, okay. Normally I do this at web developer conferences and I get a whole bunch of 15-year-olds going like, huh? HTAs were this really weird thing. It was HTML application or something like, anyway. And the concept of an HTA was effectively an HTML file that you saved. That was it. Like you could remove some of the browser Chrome, like the URL bar and everything, but everything else was just that. So if that doesn't sound super useful, then you agree with a vast majority of people in the world because no one really used them. They were used to power a couple of things like the add remove Windows system pieces inside of the operating system. That was a HTA. Most Windows 95, 98, and 2000 help files, you know, that kind of weird yellowy background, those were HTAs. Outside of that, they didn't really see a lot of uptick. The concept of having something offline was great, but having to put everything into a single file kind of sucked, and so it didn't really work or take off. The next major evolution for offline ability was this project called Google Gears. Now, Google Gears wasn't something built into the browser. It was, as you could guess, a plugin made by Google back in the early 2000s, but it brought a lot of really fundamentally new pieces of web technology to web developers if the user installed it. This is a logo for the worker pool. This was a concept of bringing threads to the browser, and it greatly influenced the design of web workers later on. They also had the storage module, which was a version of SQLite inside of the browser, ultimately influenced and created the Web SQL specification that is now deprecated. And then perhaps most pertinent to what we're talking about today, they also added the offline module. Offline module let you define a whole bunch of files that could be pre-downloaded and pre-cached and saved on disk. It worked really well for a certain subset of problems and ultimately led to the design of a thing called App Cache. I don't know about you, but the thing that I remember the most about App Cache is this talk. It's App Cache is a douchebag at JSConf a number of years ago. That's Jake Archibald. He's one of the developer relations people at Google Chrome now. At the time, he was working at Lanyard, the popular website for tracking conferences, and they had just tried to implement an offline website, and he had a lot of feelings. App Cache is a really, really awful API. And it was led us down the wrong road for a long time. The problems with App Cache, which whenever I'm dealing with technology, I like to make sure I know the mistakes of the past so that we can properly avoid them in the future. So an App Cache, the way that it looks is it's an actual static file. So you can think of this as the contents of an App Cache file right here below the title. To walk through it, at the very top, you had to define cache manifest just by saying the word cache manifest for some particular reason. After that, you had to add a comment because a file had to be different whenever you updated it. So take, for example, you updated that index.html file, but you didn't update that comment, the app cache would never, ever look for new content. Your old version would stay up there forever. If you didn't add a content, that means, and your users downloaded it, theoretically, they would never get an update until the heat death of the universe. Because app cache is terrible. There's a lot of problems with it. Not only that, you'll look in the files, you'll notice there's that kind of cache.html and one with the query string. That's because app cache views those as two unique files. So imagine if your query strings were nearly identical or generated on the client or all these other things. All of a sudden, those are unique files, and the app cache thinks they don't even have it locally. It's a terrible API. It enabled some functionality, though. Problems were that, like I said, it's a static list of files. If you have anything that's generated client-side or user-specific, it's nearly impossible to actually maintain all those things. It always takes over, even with your offline, or even when you're online. So because there's no way to know whether or not you'll have content that loads in 200 milliseconds or 1 millisecond or anything else, if you have an app cache installed, it takes over the entire domain and assumes that everything it doesn't have is offline. So unless you declare it inside of your app cache manifest, you are no longer able to access it. Even if you have the fastest internet speed in the world, the app cache thinks it doesn't exist. And again, it will only ever update if the app cache caches itself, which sucks. Not only that, all redirects are treated as failures. So if you don't have a 200 HTTP response on something, it's treated as a 404. If you redirect, it's offline. It doesn't exist. It sucks. And then probably the worst thing is the fact that you can actually cache the app cache, in which case nothing will ever get updated no matter what, even if you comment stuff, because browsers never go and check for the new file. It's really terrible. It's a horrible API, and it sucks, but it exists. And not only that, it greatly influenced the design of service workers, because we wanted to make sure we didn't do any of this. So in order to find out why service workers don't suck, we're going to dive into a couple of examples of how to implement them. So very first step of using a service worker is the registration part. Registration inside of a service worker ends up looking like this. So we dive in, first of all, by doing a feature detection. Service workers are currently supported in Google Chrome for over a year now. Firefox has them as well. On Edge in our upcoming version 16 on October 17th, the fall creators update, they'll be available behind a flag, and then they'll be available by default in the following release, Edge 17. Safari recently stated that they started development for it, both on desktop and on mobile. But for right now, it's not something that you can reliably expect to exist in all browsers, so you definitely want to do some kind of a feature detection. In this case, we're just going to check for the API, navigator.serviceworker. We're just going to see if it exists, and if it does, it obviously returns a boolean of true. So now that we know that it exists, we can start using it. In this case, we're going to call navigator.serviceworker.register. This is a new API, obviously, and all it does is take a URL inside as a function parameter. So you pass in a string that represents your external service worker file. And that specific file, where you have it on your domain, is actually particularly important. And the reason is for security. See, if you load it like this, we're loading from the file as like example.com/serviceworker.js. It's being loaded at the root. As a result, it's going to be able to control the entirety of that domain. So imagine if you were a website that hosted other people's files, whether it's a forum, an email service, or code examples like CodePen or JSBin, things like that. If somebody was able to upload a service worker file and take over the entire domain, that would be terrible. That's the app cache model from before. You load an app cache anywhere, it can take over your entire domain. With service workers, we wanted to have it scoped. And so there is this implicit scope with wherever you load a service worker file from. Effectively, you will have control over the path location of the file you load it from. Since this was loaded from the root of the website, it can control the entirety of the website. This one, for example, if we load it from /js/serviceworker.js, we can control any URL that gets loaded from /js. So there is an exception to that, and that is if you do your registration process, you also enable this secondary argument, which is an object where you can define a scope. So that scope is just it's just a additional parameter that allows you to do that. It has to be served, the request that loads the service worker has to have a special header that will actually tell you, it's right there up at the top, service worker allowed. And if that file is not served with that header, it will fail out. Otherwise, if you have service worker allowed as a header with that correct path and you change the scope down there, it can control the entirety of the domain. It's a little more complex, but some people have some really complex server setups, so we try to make sure that everyone can be happy. So next step is making sure you understand how to handle failure. So this navigator.serviceworker.register API is a async API. As you can imagine, it's loading a file from the network. And pretty much all new async APIs that are in the browser are promise-based. Promised is a new JavaScript feature that's been around for a couple of years now. The idea is that any promise API has this additional thing that hangs off of it called .then. They're sometimes referred to thenables instead of promises. But the idea is that you have this API, and then once it has completed this, you pass in a function to .then to do something with the result. So in this case, we don't particularly care if anything happened inside of it. You can do something like announce that the site's available offline inside of that callback or whatever, but it's not particularly useful. It's just making sure you're available or aware of it. You do get this optional object called registration, which we'll go into in a little bit, but otherwise it's not particularly useful for most use cases, in my opinion. Ultimately, the thing that is important is this catch. In addition to thens, all promises have the catch API. Catch API is the exact same thing. You just pass in a function, and in this case, it's giving you an error. Promises by default, so like do not throw by themselves, you have to catch it inside of that catchable. So navigator.serviceworker.register, if there was a problem, it wouldn't throw in the traditional JavaScript sense. It would error out, but it wouldn't necessarily stop all execution like most JavaScript, like a syntax error would. So you'd have to catch and be able to tell what sort of debugging steps you want to do inside of that. So you could do something like just console log it out for local development. If you're doing it in production, I'd recommend checking out navigator.sendBeacon. This is a fairly new API that sends a error result to a URL, and the great thing about it is that it can do it out of band. So like if there is an error and the user closes the page or anything else, this will continue to send in the background. It's an external browsing thread, effectively, or a networking thread. It's really useful. So jumping into actual service workers, now that we understand how to register them, but without getting too deep, I want to talk about the name, because it's like kind of weird. It confuses a lot of people. Like, why is it called a service worker? And the reason is because of web workers. Web workers are a feature that have been around on the web for a really long time. It was actually committed to WebKit nearly 10 years ago. And the idea of a web worker came from worker pools from Google Gears that I mentioned before. And the idea is an external thread inside of the browser. So effectively, if you've ever had to implement like a scroll handler on a website and it gets really gross really quickly, it's because the browser has a single UI thread. We don't know for a fact that a piece of code that you're handling inside of a function handler or anything like else isn't going to completely change the layout of the page, so we can't be doing async layout operations at the same time. Everything happens in serial. However, it makes sense to be able to do a lot of external processing sometimes, and well, we want to be able to allow for it. So you can use a web worker to do that. The idea of a web worker is you have this API it's just window.worker, and from within there you're able to pass a URL to an external file, just like you do a service worker, and that loads up an external thread inside of the browser. From there, you have the post message API that hangs off of the new worker object that you've created, and that allows you to just send an object, a data blob, or a string from your main thread over to the external thread. From there, it does something with that data, depending on what you want to do, and when it's done, it returns back a result. So you don't have direct access to the DOM inside of the service worker, inside of your web worker, but you do have the ability to do anything you can do in native JavaScript. You can do a lot of complex, heavy-handed calculations, but you won't be able to necessarily change an item on the page. So key things that are different between a web worker and a service worker is that a web worker reacts to content you send them. You will have to send out a string to get processed by a web worker. Service workers, on the other hand, react to external requests. See, a service worker you can almost think of as a proxy inside of the browser. It's able to respond to network requests and process them and then send them back. That's how it's able to power offline experiences. It's able to catch network requests, cache them, return other requests, do all kinds of fun stuff. So what does a service worker even look like? It is a JavaScript file, as you can imagine, and the most simple version of it can start off like something like this. We have self.addEventListener, and that self kind of throws off a couple of people, so just to make sure we're all on the same page. Self, if you look at if you're adding like a regular page load event in a normal JavaScript file, you probably write something like this, where you add event listener, and then you load, and then you do something. The problem is that window is not a JavaScript concept. It's a DOM concept. It's something built in by browsers. And because of a web worker and a service worker don't have access to the DOM, you need a way to refer to a global object. Window normally refers to the global object. So we created a new thing called self. And that's the global object inside of all worker-based contexts, service workers, web workers, et cetera. So if you ever see self, it just means the global state inside of the service worker. And in fact, we actually created a thing inside of browsers now called window.self, which just refers to Windows. And so you can actually just rewrite everything as self all the time, and it'll work. That way you don't have to do that weird cognitive switch thing. Yeah, it's great. So anyway, we have this. So self.add-event-listener install. This is the install event. And the other thing I'd like to point out is the function syntax at the end of here, right here. That's ES6 syntax, which is really cool and fun. ES6 is substantially smaller amount of code most of the time. You can write things in a cleaner way with less boilerplate. The problem usually is that there's not a lot of implementation status of ES6. It's supported in all major browsers now, but you still have to support old versions of IE or mobile Safari, things like that. The great thing is that service workers, this is this current support for service workers, and this is the current support for ES6. And as you'll notice, all service workers support is inside of ES6. So when you're in a service worker environment, you can write ES6, because no browser has implemented service workers without already also implementing ES6. So you can write more modern code without having to cross-compile or feature detect or anything like that. So now we can actually get into it. I'll stop explaining random other things. And we have that the install step. So the install step is something that runs when you initially load a service worker the very first time. What that means is that if you browse to a website that has a service worker and it registers, the install step fires that time. The next time they come back to it, it won't fire. It's just that initial beginning step of it. It would fire again if your service worker gets updated, but every single time they browse, it doesn't. So what that ends up being useful for is effectively to cache items. So you can go out and pre-cache a whole bunch of stuff, keep it on your network. What that cache ends up looking like is, oh, that's a broken slide. What that cache ends up looking like is a new API inside of service workers that actually allows you to keep entire network request objects. So not just the body of that request, but the headers, just the entire network. So if you've ever opened up like the network pane inside of your dev tools, anything that's inside of there will be available inside of these network objects. You can cache and store them. It's really powerful. They're actually really similar to a lot of other storage APIs. You can think of it as effectively a new storage API. And we have a lot of those in the browser. IndexedDB is very similar. In fact, the polyfill for cache was originally built off of IndexedDB. There's stuff like local storage and a whole lot of others. There's a bunch of ways to store information in the browser, and so it's kind of painful to add yet another solution. But it was necessary, like I said, because we want to be able to store the entire network object. We want to store all HTTP headers, the content body, just everything that exists. And so we needed yet another primitive in order to do it. The way you use it ends up looking kind of like this. So a cache is a new concept that exists in service workers, and you can create multiple caches off of that global. So the idea would be, say you're shipping a whole bunch of code that gets updated once every week or once every 2 weeks, but you also have library code that gets updated every 6 weeks. You can store the hot updated code in one cache, the cold stuff that stores longer in another cache, and then wipe out that hot cache much more frequently. That way your users don't have to keep re-downloading that content. So what a really common step is that you define a cache that you want to download that you guarantee for a fact all users are going to need. So in this case, we're going to do our pre-caching step where we cache the root of the domain, our CSS, and our JavaScript files. And so once we have that defined inside of our install step, we're able to dig into the actual event. So like I said, this install event happens the initial time your service worker is loaded. And so we grab that initial install event. Now, service workers are not like web workers in the way that when you open up a web worker, it's constantly running in the background until you no longer need it, the page closes. Since service workers are something that are very long-lived, they can actually exist outside of the context of the browser, meaning the browser can be completely closed. Service workers' lifetimes are generally not going to be nearly as long. They get killed and restarted fairly regularly. As a result, for things that might take a long time, like pre-caching a whole bunch of assets, we have this wait until API. What that effectively is saying, it's a signal to the web browser, say, hey, I promise I'm not doing a while true loop and mining for Bitcoin in the background. I'm trying to do something actually useful here. So this browser is going to allow you for a longer amount of time before actually killing the service worker thread. So we say, hey, I'm trying to do some stuff here. And then inside of that, we're going to pass in a caches object, and then we're going to open the cache name. So we're saying, in this case, we're going to create a new cache or open it if it doesn't exist, or if it already exists, the cache name of v1. And again, it's an async operation. It's a creation of a database, effectively. And so we have yet another promise interface. We grab into the then, and then from there, we have a callback inside of our thenable. We'll get a reference to the specific cache, the v1 cache that we're talking about. And then once it's done, we can log out some debugging messages and then call in cache.addAll, where we pass in an array of URLs that we want to download. So the cache.addAll is a really nice interface because it allows you to pass in an array of URLs specifically, or entire request objects, meaning after they've already been requested and returned to the browser, and it'll store all of them in serial. It will return it's a promise API just like the other one. So if it returns successfully, all APIs get all URLs get cached. Then will execute, and if any of them return a 500, anything like that, it'll throw into the promise catch-based interface. Excuse me. So. Cache.addAll is not the only caching API. There's a fair amount of them. There is, like I said before, it is just an array-based interface to add any URL or request object. There's also, as you can imagine, cache.add, which is the exact same thing, just one at a time. There's cache.match, so that allows you to pass in a URL or a request object and then check to see if it's already cached. That way you can return it if you're offline. Without having to go to the network. There's also cache.matchAll, which does, as you can imagine, the exact same thing as addAll, but for match. There's also cache.put. Cache.put is kind of an annoying one. The idea is that, so a service worker, the whole point is to make your application work offline. And realistically, most websites that are made today don't actually control all of the content on their own domain. They're loading in things from ad networks, Google Analytics, stuff like that. And as a result, it needs to be able to have those files offline in order to be useful. However, at the same time, we don't want websites to be able to access our users' data from external URLs. That would be a huge security vulnerability, right? Since we don't want our service worker to even control assets from other domains, or if they're loaded from other URLs, we certainly don't want people to be able to randomly access our Facebook credentials or anything like that. So what cache.put allows you to do is store what are called opaque responses. An opaque response is the concept of a response from Google Analytics or an external domain or any other place that's not a URL that you control, without actually having access to the request body or the headers. Basically, you're given the idea that you are being presented a black box of HTTP response information, but you can't inspect it, you can't look into it at all. So the browser can take care of everything, but you as your JavaScript interface can't. So cache.put is exactly like cache.add, but for opaque response, but it supports opaque responses. So generally speaking, you almost always want to use cache.put instead of cache.add. I honestly don't know why it's two APIs, but we all make mistakes. Then there's cache.keys that allows you to iterate over all of the different URLs effectively that exist inside of your stored cache information. And ultimately cache.delete, which allows you to delete a cache. So I made a lot of references to HTTP responses, objects, and stuff like that. And in order to really understand what I'm talking about, we need to go into a new API called fetch. So the fetch is an API and an event, and those are kind of two separate, unrelated things, unfortunately. Again, naming is hard. The idea of a fetch event that we're going to go into is really integral to a service worker. A fetch event is something that's fired every single time you go to the network, almost. So that means, XML, AJAX requests, obviously, that'll trigger off what's called a fetch event inside of your service worker, and the service worker will be able to grab it, control it, and respond to it. Image requests, any assets that are included inside of your page, so CSS, images, external files, HTML imports, all of those things will trigger an event inside of your service worker that your service worker can respond to. loading a CSS file, even loading an asset inside of a CSS file, basically any network request. There is a very small amount of exceptions to that, one of which would be the service worker registration object itself. We don't want people to be able to never have an updated service worker, so a service worker can't intercept its own registration request. It's weird, but technically possible. So now that we understand fetch, we can go into what is kind of like the easy mode, or the initial cache-only version of a service worker. Generally speaking, this is something that almost all websites can implement today to pretty greatly increase their speed and user experience. What it ends up looking like is this. So, excuse me, this will be just below that install listener that we outlined before. And the idea here is that we're going to use that new fetch event. So again, a fetch event is triggered on any network request individually each time. We get that event object, and what we can do here is respond to that event. So at this point in time, we actually have intercepted, like a proxy, the actual network request from the client, and we're going to look at the event and check to see whether or not we have that information cached. We do that by using cache.match. From there, we pass in event.request. So event.request represents that HTTP response request object that I mentioned before. And what that does is it grabs the URL inside of that event.request, checks to see if we've already stored it inside of our cache. And if we have, we get a successful promise response with a result. If that result exists, we can just return it immediately. That means we have already cached that response from of that URL, and we're able to give it back immediately. So you can think of like your CSS assets, your JavaScript stuff that's not dynamically generated on the server can be completely stored in the client and available offline immediately. If you don't have it, what ends up happening is we end up calling into fetch. Now, like I said before, fetch is both an event and an API, unfortunately named, but it's still a really useful API. The idea of a fetch API is effectively an AJAX request with a promise-based interface. So you can call fetch like this, and it will request the URL object. It'll then be a promise, so you have .then, .catch, just like you did with the other stuff, with the response information. The reason why it's great is it replaces this inside of a AJAX request. AJAX was the XML HTTP request object is something that was invented back in the IE4 days for Outlook Online. And the API has not exactly aged well. It's really gross and verbose. And so fetch is a more modern way to interact with network responses. And generally speaking, it's what you want to use moving forward. And in fact, it's the only thing that's available inside of service workers. You no longer have the XML HTTP request. You only have fetch inside of service workers. It's effectively the jQuery request objects like we've had for a long time. So moving back into the actual fetch request, what it looks like is you have fetch, and you can pass in the same event.request. Again, that'll represent the entire request object, but fetch is intelligent enough to be able to reach into it, grab the URL, and then act appropriately. You don't have to grab the specific string out of it yourself. It's an async API, and so it is a promise, so we have a venable. So effectively what's happening is we didn't have that request cached already, so we're falling back to another network request where we've requested the original URL that the user requested in the page. And then once we get the request, we're going to put it in our cache. In this case, it's kind of a really naive example because we're not accounting for dynamically generated content or things that we don't want to cache. But I'm assuming on this particular page that everything we ever request we're going to want to have added to our page. So we do cache.put because, again, it might be an opaque response. It might be Google Analytics or external CDN files. We're going to store the key event.request by the response.clone. So we're adding to our database, the cache database, based off of the request object, which, again, can be looked up by URL or the entire object. And the data, or the value that we're storing inside of that key value store, is a cloned version of the response. The reason is because responses are stream interfaces. This is a new concept for most web developers, but basically, imagine if you were downloading 10 terabytes of data inside of your browser, which you shouldn't, but you can. If we tried to store all that in your cache, we would have to block until we write 10 terabytes inside of your memory before we return it to the browser. It's dumb. So what happens, with streams is they can only ever be consumed once in order to prevent that kind of blocking behavior. So you do response.clone in order to basically clone that response, start writing over here, and you can immediately return that data to the user so they're not blocked waiting for it. So the response that you've returned there fulfills the new fetch response, which fulfills the event.respond. So from a user's perspective, they've basically got if it was cached, it gets there much, much faster. And if it wasn't cached, they get it in effectively the same time. There'll be a couple of milliseconds additional latency just for the logic of it, but they're really nothing perceivable. And that way you can have something completely offline and available. It's really, really cool, and it makes a lot of websites a lot faster. However, like I said before, it can be a little naive. For example, it didn't really account for any kind of file updates. It just kind of kept on adding stuff to your cache and expecting you to know when to blow everything away in the future. Realistically, that's probably not what's happening on most people's websites. And so we can graduate to a more medium mode of cache and update. Now, this is actually extremely similar to the easy mode that we went through before. The only difference is that before we did an event.respond with of the cache, and then immediately, if that wasn't in there, we went down to a new fetch. In this case, we're going to only respond with the promised value. If it doesn't exist, it will just respond with a blank value. And what we end up doing is going into an additional event in order to fire off another network request that we can send a response to in a moment. So what we do is we immediately reply with a cached value, even if it's empty. And then if it's not, what we do after that is we call event.waitUntil to extend the lifetime of the service worker. And then from within that, we request it every single time, no matter what. So if it's cached or not, we always request it in the background. And the reason is because we want to know whether or not that file's been updated. And so what ends up happening is that we do the exact same code as we had before, but then in addition to returning that response every single time, we call another venable. In this case, we're calling refresh. Refresh is not something built into the browser. It's a function that we can create like this. And the idea of refresh is that you can immediately request that API and then send out the resulting response object to every single browser, that tab or window that's open, and they can figure out whether or not that file's changed. So the idea of refresh is that you can call self.clients. Now remember, self is global, meaning, and what clients is kind of a new concept inside of a service worker. And the idea is that previously when you register a web worker, every single tab that opens a web worker, every single web worker that's opened is its own individual thread, effectively. They never really meet. They're not shared. With the service worker, on the other hand, every single page that registers that same service worker URL will share that service worker, theoretically. It's up to the browser. We can split it into 15 different background threads. We can have one thread powering 100 different tabs. The idea, though, is that self.clients gives you a reference to every single page that has access to that service worker. And so what self.clients.match all gives you is a reference to every single one of those tabs. So what we're able to do is call self.clients.matchAll, get a promise-based interface available. So then once we have that, we'll have an array that represents every single one of those clients. For each client, each one of those clients, we're going to create a message object. This is just a very simple object. We're going to call it a type refresh. This is in no way necessary. It's just a random key value that I'm adding to it so that I can understand in my own logic inside of the JavaScript. Again, we're assigning a URL, which has no special meaning. This is just the response.url from that request that we've fetched from, or from the response, sorry. And then we're also going to grab the e-tag. I mentioned a couple of times that service workers lets you actually access the headers of the request. This is an example of how you can interact with them. From the response object, you can call .headers, and you can get the actual e-tag value. E-tag, if you're unfamiliar, is a hash that represents a specific version of a file that's based off of the time that it was last updated on the server. It's on a lot of people's headers by default, but it's just a way to uniquely identify a version of a file. Once we have that message created, we can call json.stringify to get a string-based version of that message, and then we post it to each individual client every single time. From within the main JavaScript of our file, where we registered it before, we can now add a onMessage handler. So this will get fired anytime that post-message API from within the service worker is called. And we define a function where we will grab the JSON data. So the event.data will represent our message object that we created before. Since we stringified it, we need to parse it to make it an object again. Then we can do last e-tag, where we look up the, inside of our local storage, we'll store each individual file's current e-tag value. And then we will check to see if that message, on that message, does the last e-tag value not equal this value? And if it does, do something. You can refresh the entire page, send an alert to the client saying like, hey, do you want to click here to refresh the page and get updated data? You can just blow it away yourself. It's up to you. So there's a lot more ways to interact with service workers. They unlock a ton of flexibility and possibilities. This is just some of the ways you can do it. If you have questions, we can dance about it in a little bit. And then there's some other APIs I want to talk about before I run out of time that are enabled by service workers, stuff like push notifications. So this is native push notifications that you can actually register. And in order to register them inside of a service worker on browsers that support it, it's actually pretty straightforward. It's just yet another event, like your install and fetch events that you've had before. And you just get an event object, and that's basically it. So you need a server to be able to push to them, but once you have the actual event, inside of it, you can choose how to respond to it. So you can grab event.data and call .json, and that will give you the actual push event object that has been pushed down from from Windows notification services, Android push notification, Apple push notification. You can also get that exact same push notification as text if it ends up just being a string, or JSON. Most of the time I like JSON. And again, we can call event.waitUntil because we're going to open up a registration or a notification object. So at this point, we've received the push notification. We want to actually show it to the user. We call self.registration. If you remember, registration was that event that represents an installed service worker file anytime that you create a new service worker. And then we call show notification off that registration object that allows you, as you can guess, to show a notification. And then we pass in one required thing, that initial string value, push.title. In this case, my push object had a title attribute. You have a whole bunch of stuff you can pass in after that. So the title would just be the title of a push notification. The body would be the text inside of it. You can add a whole lot more objects inside of it, stuff like an icon, custom actions if you want to get buttons inside of it. You can do a whole bunch of really neat stuff. They're still not widely supported push notifications, but all browsers are committed to bringing to it. So within the next year and a half, you'll be able to do these push notifications through a permissions prompt pretty easily. So back to my toy example website, I had created a service worker on the page in order to power it offline, and I was really excited. I had worked like a half hour to get it work offline and like 2 days to get circles on the page, and I was stoked. So I called Katrina into the room, and I showed her my phone and how it was working, and she was like, oh, cool, let me try it on my phone. And she opened up her iPhone and got that. And the reason was because service workers aren't supported on mobile Safari. They're coming, but they're not there now. And so realistically, an API coming in a year and a half, 2 years doesn't help my baby today. So Katrina's not really interested, and that sucked because it kind of deflated my balloon. But I still wanted to have something that worked offline. Again, I need something to help my baby stop crying today, not 2 years from now. And so I started to think, how could I possibly make this work? And I had a terrible idea. It was to use app cache. And remember, app cache is terrible. It's a really, really bad API. I hope I made that clear. And service worker is substantially better than app cache. App cache is actually so bad, it's being removed from the HTML spec. They're like trying to purge it from history. They don't even want to remember that it was that bad. They've almost never done this. I can count on 2 hands the amount of APIs that have actually been removed. But it covers our use case. So even though it's a terrible API, there were use cases where it made sense. And so one thing that it really bothers me is when web developers write off entire technology fields simply because it's uncool or it's bad in a lot of people's situations. If you understand the sharp edge cases, you can kind of know how to handle it and actually use it in production in a really useful way. Not only that, it's supported everywhere. See, it's a bad idea, but it's an old bad idea, and so all browsers implemented it. It's been around for nearly 10 years. And so what we can end up doing is this little dance in order to actually kind of support both. If we only want to store a collection of files. Remember that application I'm making is effectively just a couple of JavaScript files, a CSS file, and an MP3 file. It's not really a whole lot of dynamic stuff. It's just a static list of files. It works. So what we end up doing is this logic. We check to see if service worker is enabled on the client. If it is, register. If it's not, we're going to fall back to app cache, which is exposed as window.application cache. If you've never used an app cache file, the way that you actually install it is kind of weird. It's a HTML attribute up there at the top. You have to set manifest equals external URL. And the problem is that has to be there at runtime. Or at load time. You can't dynamically add the manifest attribute and have it add anything. And so, it's kind of hard to be able to fall back to that. We don't want it to be there by default because we wanted Service Worker to take it over. We were afraid that app cache would, take over everything. So what we end up doing is a little hack. We create a new iframe, we hide it, and we set its source to be a specific HTML page that just loads the app cache, and that's it. And then we append that iframe to the page. And because iframe is terrible, because app cache is terrible, it takes over the entire domain, even though it's inside of an iframe. So we just load this HTML file inside of it, and after we do that, all the content that we have inside of our app cache can be cached and available offline. Again, app cache is a terrible API, but what it was able to do on Katrina's phone was take that website in our really slow connection, because we're in an old building, from about 20 seconds to 190 milliseconds. It's a huge impact that you can have. Like, even though, when you're testing these experiences that you have on your websites, make sure you're testing on slow connections and bad devices, because realistically, a large portion of your users are probably there. Now, after I made it work in app cache, I felt dirty, and I was trying to think of how much more could I push this offline experience. And I was remembering that the idea of an offline application is not something that's new. It's something that we've been trying to do for a really long time. And so I decided to make that website into an HTA as well. So if you actually load Hush Little Baby inside of a version of Internet Explorer that does not support app cache or service workers, which is IE 8 was the last version that didn't support application cache, you'll actually get this huge ugly banner because you shouldn't be using Internet Explorer. And you click on it, and you actually get an installed version of the website inside of an HTA. And this is a terrible idea. No one should actually be doing this. But I want to kind of illustrate that PWAs aren't necessarily a radical new way to create websites. This can be a radical new way just to update websites. These are features that can be incrementally layered in through feature detection in order to make your website work better. I could have shipped that exact same domain 20 years ago, and it could have just added these feature detections for service workers, and it just would start to work when the browsers come. I have something that works in a browser. It worked in IE4. I found somebody that still had it on a machine at work, and it worked. It worked there, and it worked fine. You can add these features now. You don't have to wait for it to be supported broadly. So I'm going to dive into some of the more APIs that you can build on to build your progressive web apps. Before I mentioned the web worker. Web workers are a really, really cool piece of tech that is really underused on the web today. It's actually, again, been around for a really long time. It was added to Firefox back in 2008, which is crazy. 2008, Edge didn't exist. IE looked like that. Chrome looked like that. Like, it was a long time ago. The web has greatly evolved. And again, why web workers were important were because the web was single-threaded by default, right? Like I said before, you can't relay out a page inside of a scroll handler because the browser needs to know what the layout is and all this other stuff. We can't trust you not to completely screw up everything, basically, inside of the browser code. And as a result, everything ends up fighting for CPU time, right? If it's single-threaded, everything's fighting for resources. So if you do something that ends up being really, really computationally heavy, it makes it really hard to use on the browser. It makes the user feel really janky. So theoretically, you can offload those tasks to external threads and make it work. And I already showed this slide, sorry. And what's great about web workers is that they're supported everywhere. Again, they've been around for a long time, nearly 10 years, and as a result, you can do a lot of stuff and have it work offline. For example, one of the things that I do in my spare time is I'm the maintainer for Modernizer. It's one of the larger JavaScript libraries on the web, larger in terms of use, not size. But the problem was that it actually was growing quite a bit in size as well. Modernizer is a feature detection library. It's a way to check whether or not different features are enabled in your browser rather than relying on user agent sniffing. The problem is that previously in version 2, it was just one gigantic file. And realistically, most people don't need to check to know whether or not border radius is supported inside of a browser anymore. You can probably rely on it, and if it's not, you don't need to know about that in JavaScript. So we wanted to make people have the smallest bundles possible, so we made it dynamic. So if you go to modernizer.com/download now, every single one of those boxes in the middle is a checkbox. And each one that you check off, you build a completely dynamic version of Modernizer just for you. That way it'll be as small as possible. One of the things we did was implement a file size counter in the upper left-hand corner that will, on the client, show you how large your file is every single time you check something off. So as you tick stuff off, it will actually update. And we did this completely client-side. We don't want to go to the server every single time to get that. The way we did that was by using a web worker. So what we end up doing is we do a feature detection. We check to see if window.webworker exists. It's supported in most browsers today, but it's never a bad idea to support feature detection. And then after we do that, we will go ahead and call a new worker object where we pass in the URL to an external file that represents a JavaScript implementation of the zlib compression library. And then we just set up a couple of listeners. So from our gzipper worker that we just created, we will create a post message interface where we'll be able to pass in the object that represents everything that's been checked off on the page. And then we will also set up an on message handler to be able to respond to the resulting gzip size that the web worker is able to calculate. So from within the web worker, this is what it looks like. First line is that import scripts. Import scripts is actually built into all workers. It exists in both service workers and web workers. And the idea is it's a completely synchronous way to load external libraries. Since you don't have the ability to AJAX in libraries or other network requests, we needed a way 10 years ago to be able to load other libraries. So you call import scripts, pass in a whole bunch of URLs that are files you want to exist inside of that, and the web worker now has the ability to run all that code. It is completely synchronous, so nothing below it will ever run before all of those things are downloaded or rejected. So in this case, what we end up calling are PACO, which is a JavaScript implementation of zlib, and prettybytes, which is a simple node module that just takes a string like 1024 and makes it into 1 KB. So that way we get that really nice little string version of the response. So we end up setting an on-message handler. This will be called anytime the configuration object with all the built version of Modernizer in it is sent over. And we say, OK, so we grab the build itself by calling json.parse on the build. And then our response object that we're going to send back is we want the original size and the compressed size. So original size will just be the length of that build passed into prettybytes. And the compressed, we end up calling paco.deflate to call the deflate algorithm. Then we pass it in with a default compression value, and we get that, and we send back the response immediately, and it works. It works without blocking the UI thread, and whenever I encourage you to go to modernizer.com, even on your phone, and check stuff off. It's still doing that compression in the background, but you would never know it. Your scrolling still works without being blocked. The checkboxes still animate, and that works really, really smoothly because it's in a web worker. It's great. So web workers can do a lot of crazy stuff. Another project I have is this thing called Web Worker Preprocessor. It's on GitHub. It's not really that useful unless you run a very specific type of website. But the idea is that we have a lot of new front-end libraries like Less, Slim, Pug, Jade, Autoprefixer, Haml, Sass, all these different libraries that have really made front-end development a lot more fun. The problem is that a lot of these libraries don't run in JavaScript. And as a result, you're not able to actually use them in an offline manner. So if you ever used CodePen or JSBin or these other kind of playgroundy websites, they don't work offline because they rely on like a Ruby server, for example. And that bothered me. I travel a lot, and I wanted to be able to have CodePen work constantly in the background. So what I ended up doing was transpiling Sass and other libraries completely into JavaScript automatically. And as a proof of concept, I made this website, offlinesass.club. If you go to it, you get this horrible website where on the left-hand side you have a complete Sass file, and on the right-hand side you have the generated CSS file that comes from that. And that works completely offline. It's 2.5 megabytes, and it's the entirety of a Ruby runtime inside of a web worker running a version of Sass, but it works. And it works basically instantaneously. Even if it takes half a second on a UI thread, that would be terrible to have everything stop scrolling or interacting for half a second. But on a web worker, that's way faster than a server response. So you can really push the web forward by using a web worker. You can leverage really ridiculous, crazy stuff. In fact, something that might be a bit more practical, and stick with me, is Pokedex.org. See, it's a website built by one of my coworkers, Nolan. And it's just a proof of concept website to show off some really performance-heavy interactions. And one of the things that he did was leverage a React-like library called Virtual DOM. Virtual DOM is one of the key things that made React, the new popular JavaScript library, really, really useful. The idea is rather than doing a whole bunch of state changes constantly, you have a gigantic object that represents all of the state inside of your application. And then whenever you change anything, you get a new response object. React will then diff those two objects, figure out all the different things that have changed, and figure out the most efficient way to manipulate the original object, usually in HTML, to be that. It's what makes React a lot faster than the original version of Angular or Knockout or these other front-end libraries. It works really great. What Nolan did was actually implement that inside of a web worker. So all that diffing, the thing that actually is computationally heavy, he does in an external thread. And what's cool about that is that he was able to get this sort of an interaction. And this is a Nexus Galaxy, which is a, I think, 6.5-year-old phone at this point. And he's getting 60 frames per second on his animations on something that's loading a really, really tall page. I mean, look, I can't get these animations on my iPhone on most websites, and he's doing it on a phone that I wouldn't give to my mother. Yeah, like, this is a really, really impressive speed, and it's a really cool implementation. I encourage you checking it out. It's completely open source. Nolan's a genius, and he's really friendly. Feel free to reach out to him on his GitHub. One of the things Nolan's really known for, actually, is IndexedDB. He's a huge advocate for it, and I think it's extremely underused on the web. IndexedDB is a way to build databases. It's basically a database primitive that other things can be built on. And again, it's been around for a really long time. It was added to Firefox years ago, and it's in all browsers now for quite some time. The problem with IndexedDB is that most front-end engineers are used to data storage interfaces that look like this. You have a key-value pair that you end up storing and then grabbing it later and it works. To do literally this exact same thing in IndexedDB, you have to do this. And that sucks. Like, this is not something, you can't convince anyone that this is not as good as that, because it's really painful. The reason why it has to do that is because local storage is much, much, much more simplistic. IndexedDB is as close to the metal as you'll probably get as far as databases go inside of the browser. It's really meant to be a primitive that other things are built on top of. Luckily, there are a few things that have been built on top of it that make it much more palatable. A great example would be Dexy.js. It's a version of, it's a database-powered library built on top of IndexedDB that gives you this nice, this is nicer. Like, it's this kind of interaction and interface where you are able to do direct database queries, like where, above, each, etc. It's really nice. If you want to do large data storage, I'd highly suggest you check it out. If you really can't convince them to get off of local storage, local forage is a good option. It's a IndexedDB version of local storage. And you can do a nearly identical interaction. You get callbacks rather than direct synchronous replies, just because of how IndexedDB is created. And the one that Nolan is actually known for, is PouchDB. PouchDB is an actual implementation of CouchDB inside of the browser. So you can do entire PouchDB database syncs. It's actually proof of concept websites where people download the entirety of the NPM metadata database, which is a CouchDB interface, in a browser. And it's huge. There's millions of packages on NPM at this point, I think hundreds of thousands certainly. And it's a huge amount of data, and you can have that stored completely offline. That's because you can do a lot of storage offline that a lot of people don't realize. I actually encourage you to check out this website. It's called the Browser Storage Abuser, and it was built by a DevRel person at Google, and you're able to use it to store gigabytes of data inside of your browser. In fact, IndexedDB can store on Firefox and Chrome up to 50% of available disk space. In Edge, it's up to 150 megabytes right now. And then in Edge 17, in 2 versions, it's going to be up to 15% of available disk space on any given volume. And on Safari, it's gigantic as well. You can store huge amounts of files. You can store offline videos, offline audio. It's not just small text files that you can be storing inside of your service workers. You can have entire offline experiences. You can check out that website here at I don't know how to pronounce that one, but you can go to it and check it out. It's really eye-opening to understand how much you can really store in a browser today. Now, coming back to PWAs for a little bit, one of the more simple concepts inside of a PWA is the idea of a web app manifest. This is a spec that's been around for a little while. It came out of the Firefox OS project. And if you've ever implemented any kind of browser extension or a lot of native development, for mobile, you'll probably be familiar with the concept of a manifest. It's really just a giant JSON object that represents a whole bunch of metadata inside of your application. Stuff like the language, the direction of the text, description, icons that are using. You can lock the orientation, so you can lock it into landscape, portrait, set theme colors, basic stuff. One of the cool things inside of a progressive Web app manifest is that you can actually tie it to related applications. So if you have a PWA and native applications, you can tie them. So if a user has your native application installed, they click on a link, it can automatically go into that application without you having to do additional setup. If you don't want to do that, you can also set the preferred related application to false. As a web developer, I hope that that's what you're doing. But you can also obviously set that to true if you prefer to get them into your native experiences. The great thing about a manifest is that it's just an external file that you load with a link tag, which means there's no way to crash your website by doing it. You're not going to have to feature detect this. You know, this can be loaded in any HTML parser since the www browser that Tim Berners-Lee wrote. You know, it's just a link file. It won't know what to do with it. It won't do anything with it, but it won't do any harm either. You can just toss it into your header, and everything will work. Now, one thing that you might have noticed with all of that metadata that's in there is that there's actually a lot of overlap with the header that you already have. We define a lot of this stuff already, right? All your icons are probably in your header, possibly your theme colors. If you ever have done a Windows 8 application, you have a config object, all these other things. That data is kind of repetitive. The manifest is trying to get all that data into a single file that can be cached to reduce your head size. But it also means that since you have that data in your header, it makes it a lot easier to onboard to get a manifest. So I actually built a node module called manifestation you can download, and what it does is it crawls your website in order to build that manifest for you automatically. And it does that just by crawling through your header and your HTMLs in order to try and build the most feature-complete version of a web manifest as quickly as possible. This is an example of the language detection. It's one of the simplest ones. What it does here is load Cheerio, which is kind of a server-side jQuery version. And then there's also CLD, or compact language detection. It's a binary version, or it's a binary file that is the same algorithm that powers like Google Translate or Bing Translate. It's a way to basically take an entire body of text, in this case the body of your page, and figure out the most dominant language inside of it. So what we end up doing is grabbing the HTML, checking to see if you have a language attribute, because you should, and if you do, it's an easy way to win. If you don't have that, however, we'll fall back to an XML language attribute. If you don't have that, we'll fall down to a Dublin Core attribute. Any librarians? No? Okay, Dublin Core is a really obscure language detection thing, but it does exist, and like I said, we want the most feature-complete version of this to be possible. So we will look up any tag that can possibly define a language and return it. If all that fails, we fall back to compact language detection, where we actually pass in the entire string of your file and try to grab the most prominent thing out of it, and we get that language no matter what, by hook or by crook. That's one of the simpler ones. This is one of the more complex ones, the image requests, and as you can tell, the number of files we're actually requesting just to figure out what images you have is almost too big for a single slide, let alone the logic to actually do it. But we end up loading, stuff from the favicons, stuff from your Apple icons, the manifest files for Windows 8 the tiles, like if you can define an icon in any way, we'll find it and we'll put it into your manifest. And well, like I said before, you can actually use this module right now by going to Web Manifest. This is, again, a novelty domain because I love them. And if you go to Web Manifest, you will get this website, and you just have a URL bar, or a text bar. You put in a domain that you want, you hit enter, and you get a pop-up, and you get the manifest file, and you put it on your page, and that's it. And it works. You're in the steps to becoming a PWA. That's all you had to do. It takes like 2 minutes most of the time, and it's really, really successful and really, really useful. There's a couple of novelty bits off of the end of the Web Manifest domain if you want to check it out. The spec is really straightforward. If you ever have any interest in digging into web development specs, it's a great one to dive into. And yeah, so one of the cool things about the Web App Manifest is because it is so declarative in this way, it makes it really easy to find progressive web apps. And so we're actually working on the Edge team with the Bing team. See, the Bing team is pretty good at crawling the internet, and they're really good at figuring out what data is on those websites that they crawl. So they can find manifest files, and actually we're working on them to import PWAs directly into the Windows Store. And you'll be able to opt out of this, absolutely, but by default, what we can do is have Bing go out, crawl, look for these manifest files. Then we can check to make sure that it meets the quality standards of our team and of the Windows Store team. and then we can automatically register those PWAs as native applications inside of Windows, even though they're web-powered. See, the way that PWAs are going to work in the Edge browser is they'll actually be HWAs, which are a version of UWPs, the Universal Windows Platform Applications, that effectively just load a website. You can think of it as a really thin native app wrapper around your website and your PWA. And what's cool is that you have you can automatically be exposed to all of the people using the Windows Store just by adding that manifest file. It's one of the things that the team's going to be keying off of, and so it's a great first step to be creating these things. Yet another exciting API that's coming into the PWA world is the Web Payments API. Web Payments is something that it's existed on Edge for over a year now. The idea is that rather than have your users fill out yet another form in order to get information from them, you can actually leverage the built-in payment information. So this would be like, for us, the Windows Wallet. For Apple, it would be Apple Pay. All these different things you can actually directly collect information from. That way you're not responsible for their credit card information. They'll also don't have to re-enter it yet again. I don't have to find my wallet to give you my money. It ends up working great for pretty much everybody. The API is actually pretty straightforward as well. In this case, we're going to define a simple object where we set a supported method, in this case basic card, which is just going to be the credit card information. An alternative would be like using PayPal or Amazon payments, things that are not actually a credit card itself. And then we also set the data inside of method data, which represents the supported networks, so all the different types of credit cards that are available inside of our network, the ones that we want to process as a company. And then supported types would be debit or credit. Once we define all those things, we create another object that is just for information. In this case, we're going to be saying the language that we want to represent the label for it, so in this case, the total amount due. And then in addition to that, we set the currency country value and the ultimate value. You can also do something like request shipping so that you can get an address if you actually want to ship something as opposed to just taking money for an online purchase, a digital good, etc. Then what's great is that you just do something like this. You say if payment.window, which is a feature request, you just call off a new payment request. So if the browser supports payment requests, the user gets that much more modern, nice UI. Even better is that if it doesn't support it, you can just go back to your old checkout. Whatever you're shipping today, you can continue to use. This is a progressive enhancement on top of it. Realistically, a lot of people, it'll be a year, couple years before everyone is on these payment request-based browsers, but you can still support old ones just by using basic feature detection. Payment request did actually come to Chrome Mobile a few months ago, and it came to Chrome Desktop pretty recently. It can really give you a taste of how great it is to call into these native APIs to have modern web applications. And now, jumping back to what I said a little bit ago, Edge-based PWAs are actually going to be UWP apps, effectively. And if you remember, back in the Windows 8 era, we actually exposed all of our operating system to JavaScript APIs. And inside of UWPs, we exposed them. And so if you actually check the window.windows namespace, you have access to the entirety of the WinRT APIs. So if you create a PWA and a user installs it, you'll have access to the entirety of the WinRT APIs from within that. That means you can leverage stuff like the Bluetooth API, media keys to control whether or not, like the play, pause, etc. on a keyboard, native OCR, optical character recognition. You can do data processing or QR code validation inside of the browser using the same APIs that powers our operating system. You can have direct access to Cortana. You can have all of these APIs that exist inside of the Windows 10 WinRT experience, you'll have complete access to inside of your JavaScript. It's a really new way to think about this, and because it's really easy to feature detect these things, you can just start layering them on today. You don't have to wait for all browsers to support them, you can just do stuff. And that's really what I want the takeaway of this whole thing to be, is that don't wait to create a new application. Use feature detection and you can start developing these things today. You can start shipping them today. I've been shipping service workers for years now, even though they were only supported on a single nightly browser at the time. If you use feature detection, it'll just work. It'll fall back to other experiences. I really, really want you to start playing now. Start using these new APIs, start playing with the fast-ring insider builds of Edge, and most importantly, try and give us feedback if you can. If you're unfamiliar, the Edge user voice is a website that you can go to request features specifically for Edge or the web platform in general. If there's something you want to see in the browser that's not possible today, go to this URL. You can upvote and encourage one another or tell the Edge team what you want to see. And almost every single release for the last 2 years has included the top few requests inside of the Edge user voice. We take this incredibly valuable feedback, and it's very, very highly regarded inside of our team. We want to hear what you have to say. And so, yeah, that's it. You can find me at Patrick Kettner on any social media, and otherwise that's my email at the bottom. And yeah, thank you very much. That's it. So, I have a couple minutes if anybody has a question. Yo, what's up? Sorry, was this for web payments? Sure. Sure. So this isn't like a version of, so the question was, how do you protect proprietary database, proprietary information inside your database? Sure. It is, well, you can certainly do some stuff with web crypto to get crazy with it, but realistically, Facebook and Gmail ship their entire company down to you every single time. People don't reverse engineer websites. It's incredibly painful. It's my job, and it takes a long time. So that being said, I understand the concern. You can't prevent it. Like, you're sipping down some kind of a code. You can minify and obfuscate code like you can on any website, but it's realistically, they're going to have a copy of it. You can think of it as sending down a binary file. They can reverse engineer binary and figure it out as well.
You can't have a totally isolated client and have a scope file service that hides that.
No, you can absolutely do complete client-side databases. It's just whether or not you're comfortable having a client-side database. If you're not, then sure, then you can't use it, unfortunately. Yeah, you'll have to continue to use APIs. You could use a browser database to store that data offline, theoretically, if you're able to store actual key value. But you wouldn't be able to have like your business logic inside of your databases completely client-side if you're not comfortable having it client-side. So, sorry. Any other questions? Cool. I have some stickers if anybody wants those.